welcome to yet another episode where we shall be looking at the possible solutions of the memorandum of paper 2 May-June 2024. Okay, so that was the cover page of the paper. Those were the instructions. We have 10 questions. There's also a special answer book that we shall be using in this particular session so that it can just help us here and there. Okay, then below that, we can see that question 1 is about the bivariant type of data. And the question tells us that the number of pages, not the number of pages, the number of 10 A4 books and their corresponding weights in grams are given in the table below. So the data is represented using this scatter plot. Okay, so we start with the number of pages that's representing our X variable, and then the weight is in the Y variable. So 85, 165, 150 with that, and so on and so forth. And then after that, they drew for us the scatter plot for that data. Then the first question, 1.1, they want us to determine the equation of the least square regression line. So one thing we said under the prediction was that it's always vital that we understand how to complete or how to use the calculator to enter these values. Okay, so I have already entered my values into the calculator and I have some answers. Okay, so remember, it's the mod. Then after the mod, you have to do the proper selections and then you choose the correct letters or the correct options. So the equation of linear regression is given as y is equal to a plus bx, or some people prefer writing it as y is equal to bx plus a. It could be a small b or a capital B, whichever. Okay, so from the calculator, I'm getting my a value as a negative 43.72, and then my b value, I'm ending up with a 2.36 if I round that off to 2 decimals. So now my equation is going to be y is equal to, say, negative 43.72. Just erase this once and rewrite it. Okay, so we said A is a negative 43.72. Then we said B is going to be 2.36. So our Y is going to be negative 43.72 plus a 2.36 with X. Okay, so that is the first part. Then we look at our next question. The next question is asking us to draw the least square regression line on the scatter plot within the answer book. Okay, let's see. Within our answer book, so these are the points. So remember what we said, for us to get the mean, okay, for the x's and also the mean for the y's, so that this is the point of interest where all the points are going to rotate about. So from my values, like I add up all the x values and then I divide by 10, add up all the y values, divide by 10. I'm ending up with the 120 for x. And then for y, I'm getting 239. So our line must rotate around this particular point. Okay, so this is going to be 120 and then 239. 239 is just like 240 approximately. So I'm going to use that as my point of reference. Then I need to draw a line so that at least maybe some points go through the line, or the line goes through some points, and see what is above and below. So there's no logic sense in this, but it's all about making sure that the line is balanced and it's close to the points. So these points are close to a straight line, okay? So if I connect something like that, sorry, that's not straight, but if we have something like that, okay? So if I'm to count, I have 2 points that are far away, and then I have 2 points that are above also. So this could be the best kind of line. We can always extend it to that negative section, but what we want is just to see the line that passes through those points. So that will be my best fit line, or the regression line. Okay, then they want us to predict the weight of the A4 page book that has 110. So from the equation, okay, remember this was our equation, and then the weight is being represented by the y. In other words, we need to find what y is if x is 110. Okay, if x is 110. So do the substitution, and then we're going to have negative 43,72 plus 2,36, but I'm going to multiply this by 110. Okay, when I punch this into the calculator, getting 215,87 grams. You can approximate this maybe to 216 grams, so that it fits the rounding within the table. Okay, so the question never told us to round off, but you can just leave it as that. Then 1.4, calculate the percentage increase, okay? Percentage increase between the book with 110 and then a book with 130. So we already have the weight with a book of 110, which was 215,87 grams. How about the book with 130? So negative 43,72 plus 2,36 multiplied by 130. What are we going to end up with? And I punch that into my calculator. I'm getting a 263,07 grams. Now, for us to calculate the percentage increase, it will be just more like the increase. I hate using that formula. I would rather say the new weight minus the old weight over the old weight times 100%. So our new weight is 23,07 minus the old weight, which is now 215,87, dividing it by 215,87. And then I'm multiplying this by 100%. So I punch that into my calculator, and then I end up with 21,87%. So that is how I would have gone about with 1.4. Okay, and then question number 2, they're telling us that 50 athletes, okay, 50 learners or 50 sports people need access to suitable training facilities, and the table below shows the distances in kilometers that they travel in order to obtain access to the suitable training facilities. They want us to complete the frequency column provided in the answer book. So let's go back to the answer book and see. Now, one thing we know about the frequency, cumulative frequency, is that it's all about adding the consecutive frequencies, okay? So the first cumulative should be the same as the first frequency. So that's a 3. For me to get the next one, I have to plus. So 7 plus 3, that's going to be a 10. And then 10 plus 20, it's going to be a 30. And then 12 plus 30, that's a 42. And then 42 plus 5, it's going to be 47. 47 plus 3, that becomes a 50. Now, remember, our last cumulative here must match with the total that we were told of the 50 learners, or 50 athletes. Then 2.2, on the same grid, they want us to draw the cumulative frequency graph, or the OGI. Okay, so One thing we need to know about the ogive is that it's plotted as the class intervals, which is like in this case the distance against the cumulative frequency. Okay, and then when we are plotting, we always use the upper class boundaries. Okay, an example between 0 and 5. Okay, so we're going to use 5. At 5, the frequency is 3. 1, 2, 3. Or the cumulative is a 3. I'll put a dot there. And then the next one will be at a 10. 10 will go with a 10. Okay, which is somewhere there. And then 15 will go with 30. 15 goes with a 30, which is that point. 20 goes with a 42. 20 goes with a 42. 42. Thank you. And then 25 is 47. 47 is slightly above 45. I'll put it somewhere there. And then the last one, which is a 30, must go with a 50. 30 must go with a 50. So that is how we're going to coordinate. And so let me use green to find the ogive. Okay, so just connect this with your pencil or whatever you're using to draw. Okay, remember it should be in the form of S. It's an S-shaped graph. Okay, now this needs to be connected to the last part of that. So that is how the ogive will look like. Then we have the next question. They want us to determine the IQR, the interquartile range. Now we know that IQR is the same as a Q3 minus a Q1. So we need to determine these values from the ogive and then be able to do the calculations as requested. So below that, I'll say that my IQR is a Q3 minus a Q1. But how do I get of the Q3 and Q1? So we know that Q3, okay, is the same as 3/4 of the data pieces. So 3 divided by 4 times the total number, which is 50. Some people prefer using 51. It's still going to be the same thing. So I'm getting a 37,5. Let me get the Q1 also. So it's going to be 1/4 times 50, which is going to be 25. So what this does is that now we need to locate the actual positions. Okay, so where do I find 35,7? So 35, no, it's 37,5. So 35, 36, 37,5, somewhere here. So I can draw my dotted line up until it meets the ogive. Okay, so we see where it's meeting, just roughly around there. And then I can drop this down. When I drop this down, I'm getting the value to be somewhere there. It's 15, 16, 17, it's 18. I'm going to approximate it to 18. So this is going to be my Q3. And then how about 25? 25 is just right there. And then didn't we have a 25 up there? You said 25 was 47. Wait a minute, wait, no, 25 was 47, not here. Okay. So 25 is just halfway between, somewhere there. And since it is distance, where did this point come from? We have a 10, we have a 15. My question is, where is this section coming from? Let me just erase this, guys. I'm sorry, but we need to fix this. There's no point here. Okay. We need to make sure we have the correct thing. So we say somewhere there. These can go down there. Just like that. So we say 25 is in between them. Okay. So this value is 11, 12, 13. Maybe we can take it to be a 13,5. Okay. So for my IQR, I'm going to get 18 minus 13,5. Okay. That gives me 4,5. That would be kilometers. Okay, so that is question number 2.3. And then 2.4, they are telling me that the families of 4 of the athletes above who stay between 15 and 20. Okay, so 4 people from this category. Okay, when I subtract 4, I'll be left with 8. So these people move to store training and decide to move 10 kilometers closer to the facility. So remember, the facility will be at a 0 distance. Okay, so when you move closer, it's like you're moving up the table. Okay. So from this, what is 15 minus 10? Does it make sense? They told me between 15 and 20. Okay. So 15 minus 10 is going to be 5. Does that make sense? Yes. It's going to be 5. And then 20 minus 10 is going to be a 10. So which means these people move from there up to that category. Okay. Because this will be 5 kilometers and then there another 5, which is 10. Then they're asking us in which interval will the number of athletes increase. So it's going to increase in the interval of 5 is less or equal to X and then less than 10. Okay. Why are we saying that interval? Because they move 10 kilometers closer. Will that make sense for them to move to this point? Is the reasoning making sense? No, it's not. It's not making sense at all. Because with this interval, it's between 5 and 10. Or between 0, or between 5 but less than 10. But they decide to move 10 kilometers closer. Ten kilometers closer. Ten kilometers. Anybody? Somebody? What do you think needs to be done? We can keep that in mind so that we continue working with it the way it is. Okay? And then just agree that it's going to be within that interval. Because if they move 10 kilometers closer, because that won't make sense. If I'm to subtract this, minus 10 is going to be a 5. Then that's okay. Let's take a stand. I'm going with that, guys. Okay, then calculate the estimated mean distance that the 50 athletes need to travel after the 4 families moved 10 kilometers closer. So minus 10 is that, yeah. So with the estimated mean, remember it's the x bar, which is summation of xf or ffx over the summation of f. So what I need to do is determine my midpoints. Okay, so I know that 0 plus 5 is 5. When I divide by 2, I get 2,5. So for my first part, I'll have a 2,5 times 3 plus the next one will be 7,5 times 11 plus, now that's going to be 12,5. Saying 12,5 times how many? 20. Plus the next category is going to be 17,5. It's 17,5 multiplied by, now we're going to subtract our 4 people, which now leaves us with 8. Plus now the next category, which is 22,5 multiplied by 5, plus now 27,5 multiplied by 3. So the answer we get here, we must divide it by 50 vertebrates. Okay. So when I punch this into my calculator, I punch that in the calculator, I say 7.5 times 11, 12,5 times, why are we saying 20? Yes, it's a 20. It is a 20. Okay. And then the learners decreased from that other category. So let's just punch this into the calculator and see what we end up with. So it's a 2,5 times 3 plus a 7,5 times 11 plus a 12,5 times 20 plus a 17,5 times 8 plus 22,5 times 5 plus a 27,5 times 3. We're dividing it by 50 and getting 13,5 as our estimated mean. Okay, so that is question number 2. We move on to question number 3. They are telling us that in the diagram, A is 3 and 4, B and C are vertices of this triangle. AB is produced so that we get S. D and F are X and Y intercepts respectively. F is a midpoint. I'm going to highlight this of that line AC. And then the angle of inclination, okay, also highlight inclination. And the equation AB is given as that, the equation of AC is given as that, okay. Can we show that K is 1/3? So what we need to do is that K is within the equation of A space or AB. We can get one set of coordinate which is A, and we use that. So I'm going to say Y is equal to KX plus 3. Where there is X, I'm going to put a 3. Where there is Y, I'll substitute a 4. So 4 is equal to KX plus a 3. I'll transpose the 3 to that side. I'll be left with a 1. Why didn't I substitute for X? I'm being corrupt now, okay? So we say this was a 3. So is equal to 3K, then divide both sides by 3. So K becomes 1/3. Then they want us to get the coordinates of B, which is the x-intercept of line AS. So we know that since our K is a third, which means the equation is going to be Y is equal to 1/3X plus a 3. Okay, but at the x-intercept or at the x-axis, Y is always a 0. So where there is Y, I'll replace a 0. I have 1/3X plus a 3. Transpose the 3 to that side. Negative 3 is equal to 1/3X. Multiply both sides by 3. So X becomes -9. So the coordinates of B are going to be -9 and 0. Then they want us to get the coordinates of C. For me to get C, remember, they told us that F is a midpoint. So if F is a midpoint and F is on the y-axis, so from this equation, I know that F is the y-intercept. So the coordinates are going to be 0 and -2. That is for F. Okay, 0 and -2. Then when I apply my midpoint formula, I can say 3. Okay, let me call this X and Y. Okay, so I'll say 3 plus X divided by 2 must give me this midpoint, which is a 0. When I transpose that, x plus 3 is going to be a 0, which means x is a negative 3. Let me do the same with the y. If I get my y plus, what's that point? Plus 4 divided by 2, I must get negative 2. Cross multiply, y plus 4 is negative 4, which means y is negative 8. So which means the coordinates of C are negative 3 and 8. Is that okay? So 3, negative 8. Why am I having negative 3 and negative 8? Because it's a negative 4 minus 4, which is negative 8. So that will be the coordinates of that. Then 3.4, they want the equation of a line that is parallel to BC and passing through S. So if I use a different color, so if we have another line that is passing through S, but it is parallel to BC. So one thing I need to know is that for as long as I have parallel lines, their gradients have to be the same. Okay, this is negative 15, negative 1. So I need to get the gradient of BC. Let me just put it this side. That's 2, no, it's 3.4. 3.4. So we said gradient of BC. So it's changing y over changing x. We had a negative 9 and 0. This was for B. And then the C coordinates were negative 3 and negative 8. Okay, get the gradient. I'm going to say 0 minus 8 over negative 9 minus 3. That becomes 8 over negative 6, which is the same as 4 over 3 negative. Okay, so since I've obtained my gradient, we were given point S, which was negative 2. So substitute this into the y is equal to mx plus, we're looking for C. So negative 2 is equal to negative 4 over 3 multiplied by negative 15 plus C. Negative 2 is equal to, by 3 is 1, by 3 is a 5. That's going to be a 20 plus C. Move the 20 that side, which means C is negative 22. So my equation is y is equal to negative 4 over 3x minus a 22. Okay, so that is what I'm going to have for that particular part. Okay. Then did we do everything correctly? Minus 2, minus 4 over 3. Okay, minus the plus. Okay, perfect. We move on. Then 3.5, they want us to get BAC. So this angle here is what they want. So one thing we need to know is that this angle is inside. If we can find this angle, it will be a bonus for us, because this and this will be interior, and then they will be equal to this alpha. Okay, what we need? We need to find alpha, we need to find this. So priority number 1, priority number 2, then we shall have our A. So what I'm going to do, since I have the gradient of this line, and that gradient is 2, I can use the inclination method to say that my alpha is going to be the arctan of 2, because we know that M must be equal to the tan of alpha. Okay, so the shift tan of 2 is giving me 63.43 degrees. And then this line has a gradient of K, which we got as a third. So A, B, O. Okay, ABO is going to be the shift tan of 1/3. And then that is giving me 18,43. And then for me to get my BAC, it's going to be 63,43 minus 18,43. I'm getting 45 degrees. Okay, so which means this is a 45, a super 45. All right, then 3.6. It is further given that the length of AC is 6√5. Let's use black now. This is a 6√5 from there up to there. Okay, what do they want? They want us to get the ratio, the area of ABD, and then the area of ASC. So if this is connected, we need to get the area of that. So what I can see is what do we know? I have a 45. I have this distance. I can find the distance AS and use the area rule to find this. And then with this small triangle here, I can use BD as my base. And then I can get this distance here, the 4, as my height. Okay, so we're going to say area of ABD is a half base height. Okay, so our base is from the origin up to point B. Those are 9 units. But then what are the coordinates of D? If y is 0, let me just use that equation. Y is equal to 2x minus 2. If y is a 0, move the 2 that side, I have 2x, which means x is a 1. So the coordinates of D are 1 and 0, which means the distance BD is a 10. So that's going to be a half times 10 times my perpendicular height, a height that makes 90 degrees with a base. I'll take just this 4. Okay, multiply by 4. That gives me 20 units squared. Then we said we need the distance of AS. Okay, AS is going to be the square root. Okay, we had a negative 15 and negative 2. Our A was a 3 and 4. Is that correct? Perfect. So if I use the x's, that's going to be 3 minus 15 squared plus 4 minus 2 squared. So that's going to be 18 squared plus 6 squared and the square root. Okay, we're saying 18 squared plus 6 squared, which gives me 6√10. Then from the area rule, I'll have a half times AS multiplied by my AC, the sine of A. Okay, so that's going to be a half, let's see, times the AS, which is 6√10, multiplied by the AC is 6√5, and then the sine of 45. Okay, so when I get these 20 units divided by this, let me simplify this. So 0.5 times 6√10. Okay, I'm multiplying it by 6√5, and then multiplied by the sine of 45. What we get? We're getting a 90. Okay, so remember the question said we get the 20 divided by the 90. So which is just a 2/9. All right, so that is what we wanted with that question 3.6. All right, question number 4. So question number 4 is telling us that in the diagram, the center that is centered at C, which is 2 and P, okay, is drawn. A is 5 and 1. That's correct. B is -3 and -3 are points on the circle. And then E is the midpoint. So this is very relevant for me. Okay. Then they want us to calculate the coordinates of E, which is the midpoint. So we're just going to have to use the midpoint formula. So we know that midpoint formula is x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. So that's how we're going to get those values. So if I call this my x1 and then y1, this is going to be my x2 and then y2. Okay. Then I'll get the 5 plus the -3 divided by 2. The order does not matter, guys. And then the y1 and y2 is -3 plus 1 over 2. Will only play a big role maybe when we are getting the gradient, but for midpoint, it's just the same thing, it's just addition. And so this is going to give us 2 over 2, which gives me a 1. And then -3 plus 1 is -2 over that. I'm getting a -1. So this point here is 1 and -1. All right, so those are our coordinates. Then the next question, calculate the length of AB. So AB, the total distance of that chord. So we can use the distance formula, okay, whereby our AB is going to be the square root of x minus x1 squared, and then y minus y1 squared. Okay, that will be the square root of. Why is it 1 mark? Is it a straightforward question? Okay, 5 minus -3 squared plus 1 minus -3 squared. Okay, I punch that into the calculator. That's going to be 8 squared, which is 64. 64 plus 4 squared, that is 16. 16 and 64, that is 16 plus 64, guys. Is it 80? I'm having root 80, that is 64 plus 16, which gives us 80. And then the square root of 80 gives us 4 root 5 units. Okay. Next question, they want the equation of the perpendicular bisector. Equation of the perpendicular bisector of AB. So when we talk of a perpendicular bisector, it's basically a line that is moving or that is passing through this point E. Okay, so it is a perpendicular, which means it makes 90 degrees with this line, and then it's also dividing the line into 2 equal parts. Okay, so for us to get the equation of this line, what do we know about this line? We only know the coordinate E, which is 1 and -1. Okay, but we can get the gradient of AB. Let me just get this side. Gradient of AB. This is 4.3. Okay, so we're saying the gradient of AB going to be change in y over change in x. Okay, which is going to be 1 minus -3 over 5 minus -3 as well. So that's going to be 4 over 8, which gives me a half. Okay, so over 8, which is a half. But we know that since lines that are perpendicular must give us the product of a -1, and we multiply the gradients. So the gradient of AB times the gradient of the bisector must get a -1. So which means that the gradient of the bisector must be a -2. Gradient of the bisector has to be a -2. And then I'll go and use my mx plus c, or the y minus y1, and so on and so forth. So I'm using 1 and -1. substitute into that. -1 is equal to, we say that's going to be -2 into 1 plus c. All right, so when I move this that side, when I move that side, I'm going to get a 1 as my c, which means the equation is going to be -2x plus 1. Does that make sense? Yeah, it does. Okay, so that is the equation. We said y is equal to -2x plus 1. And then 4.4, they want us to show that p is -3. P is -3. Okay, so from theorem number 1 of Euclidean, we know that if a line is perpendicular to a chord, and then this line is bisecting the chord, automatically that line must be passing through the center. Okay, so I'm going to use this equation of -2x plus 1. Where there is x, I'll replace it 2, which have been given already. So my y is going to be -2 into 2 plus 1. So -4 plus 1, that gives me a 3. So we're saying -2 times 2 plus 1, which is a 3. Okay, that's why it's just those marks. Okay, then the next part, we know that now this one is the 2 and the 3. They want us to determine the equation of the circle in this format. So what we do in this case, from our x minus a squared, and then y minus b squared is equal to r squared. What we need to get here is our distance. Okay, so if I connect this to a, I need to get the distance CA, which is going to be my radius, so I can get the distance CB either way. So we say CA is going to be the square root. The coordinates there are 2. This is a negative, okay, 4 and -3. And then our A is 5 and 1. A is 5 and 1. Let's do the substitution. So it's going to be 1 minus -3 squared plus 5 minus 2, that's squared. Okay, when I punch that into the calculator, why must I find CA? I can get 5, because this is going to be 4 squared. This is going to be 3 squared. So under square root, that's, so our CA is that, and then the CH squared is going to be 25. So do the substitution. That's going to be x, the center coordinates, -2 squared, and then y plus 3 squared. We switch the sign because that's a negative, is equal to 5 squared, which gives me a 25. Open this up, expand. So that's going to be x squared. Okay, plus, not a plus, it's a minus, since we have a negative there. So that's -4x plus a 4. And then plus y squared plus 6y plus 9. I can transpose the 25 that side. I have my 0. Group everything. So x squared plus y squared minus 4x plus 6y. So 4 plus 9, that's 13. 13 minus 25, we get a -4. So that is the equation that they wanted. Okay. Then 4.6. 4.6, they are asking us to determine the values of t for which the straight line tx plus 8 will not intersect. Right, then question number 5, they're telling us that if sine of 40 is p, can we write each of the following in terms of p? So this in most cases deals with reductions, and you need a sketch. We might, but let me see. Okay, if I just draw my sketch just in case. Okay, we don't care about the quadrant in this case, so right angled. This is going to be a 40. Since it's a sine, it's the opposite of the hypotenuse. And then this is going to be a square root of 1 minus p squared. Okay, so if that is true, I have the sine of 220. So in which quadrant we find 220? So from our Cartesian, that's a 0, that's a 90, 180, and then 270. So which means the 220 can be located between quadrant number 3. Okay, so quadrant number 3 is also known for being a 180 plus theta. So this is going to be the same as the sine of 180 plus 40. When I reduce this, it's going to give me the negative sine of 40. And we know that the sine of 40 was a p. So we're going to get negative p there. Okay, then the next part, they're asking for the cos of 50, cos squared of 15. So we know that from this triangle, if this is a 40, automatically this is going to be a 50. That's if I choose to use the sketch. And then for cos, I know that cos is adjacent over the hypotenuse. So that's going to be p squared over 1, or p over 1 squared, which is the same as p squared, because we know that 1 squared will always give us just a 1. Then the next part, let me just do this with my thickness on the smallest. Okay. Then the next part, they want us to get the cos of negative 18. So we know that the cos of a negative angle is the same as the cos of a positive angle. Okay. Then 80 is twice of 40. So that is 2 into 40. When I simplify this, the double angle of cos, I can have 2 cos squared of 40 minus 1. Okay, let me just fix this. So we're saying 2 cos squared. Okay, from the formula page, we have 3 formats of cos to theta. So we know that the cos of p is adjacent over which is a p. So it's going to be 2 like p squared minus 1. And then that's the answer I'm going to end up with. Does it make sense though? Remember, it is cos squared minus the sine squared, 2 cos minus 30. Oh, sorry, we're using, oops, as this, I'm using 50 instead of 40. What's wrong with me? Okay, so cos is adjacent over hypotenuse. So it's going to be 2 into the root of 1 minus p squared. It's going to be squared. Then minus 1. When I open that up, it's going to be a 2, the root sign will fall away, 1 minus p squared minus 1. Open this, so I'll be left with the 1 minus p squared. That's going on. 1 minus, this is a 2 minus 2p squared minus 1. So it's a 1 minus 2p squared. Yes. So guys, alternatively, instead of us breaking this into, we can use the sign that it is 1 minus 2 sine squared of 40. So that it can just give us 1 minus 2 p squared. Straight away instead of going through all of this. Okay, then question 5.2. They're telling us that we are given the tan of x to be, or tan x into 1 minus cos squared plus cos squared x is equal to this, which is the right hand side. And then they want us to prove the identity. So with proving identities, it's advised that you start from one side that has quite a number of terms, but from either way or from both sides. We can start from the left, we can start from the right, whichever one would make life easy for you. So that is 5.2. I'm just gonna try to write down that question. So we have the tan of x into 1 minus cos squared x plus cos squared x is equal to the sine of x plus the cos of x. 2 into 1 minus, I'll say sine x cos x. This is all over cos x. Okay, so this is how our question is. So I'll say sine x over the cos of x. Let me keep the 1 minus cos squared x, and then let me change this to 1 minus sine squared x. I'll say over 1. I'll do my cross multiplication, sine x into 1 minus cos squared x plus the cos x into 1 minus sine squared x. Everything is over cos x. Okay, let me try to open up. I'll have sine x minus sine x cos squared x plus cos x minus sine squared x cos x. Everything is over the cos of x. Okay, what's common? What's common? This is a sine squared. This is a cos squared. Let me regroup. I'm going to group this with this, then I'll group this with that. So I'll have a sine x plus a cos x. Okay, then I'm going to have negative sine squared x cos x minus sine x cos squared x. Everything is over the cos of x. Okay, let me see if I can break this down. So this is going to be a sine x plus a cos x. Let me take out what is common there. So if I take out the negative, I'll be left with a positive inside. So there's a sine, there's a sine, there's a cos, there's a cos. I'm taking out sine x cos x. I'll be left with just sine x there plus cos x there. And then I take out what is common. So sine x plus cos x is out. I'll be left with 1 minus sine x cos x. Is that what we have? 1 minus over that. Perfect. So we need to just divide this by cos of x. So you divide by the cos of x. So this is equal to the right hand side. Alright. Then 5.2. For which values of x in the interval this and that should the identity be undefined. So for an identity to be undefined, the denominator must be equal to 0. Okay, so I'm going to use the right hand kind of expression. So if I get my cos of x is equal to 0, I can find the reference angle. So the cos of 0 is equal to x. So that's going to be 90. The negative 90. So those are the two values that we get. Then if we are given this expression, without using a phi theta, simplify the expression to a single trig ratio, 6 marks. to a single trig ratio. What are we going to do? What are we going to do? Okay, so what I'm seeing, is I'll say the sine of 150 plus cos squared x minus 1. This is everything over. So where do I find 150? It's in quadrant number 2. If I look at my Cartesian, this way I fit this. So 50 is the same as 180 minus a 30. So I can have my sine of 180 minus a 30 plus cos squared x minus 1 over 2. When I reduce that to the simple sine 30 plus cos squared x minus 1, and dividing everything by 2. But from our special angles, we know that the sine of 30 is a half. Now I'm getting a half minus 1 plus the cos squared of x divided by 2. So a half minus 1, that gives me negative half. Okay. And then negative a half, I'll say cos squared x minus a half. Everything divided by 2. My fractions, I'm going to have 2 cos squared x minus 1 over 2, because the denominator is 2. Okay, and then I'm multiplying this by 1 over 1, because this division will be multiplication. And then I know that 2 cos squared minus 1 is the same as cos 2x over what's 2 by 2, that's a 4. So I can call it cos 2x over 4, or simply a quarter cos 2x. So that is the single trig ratio that they wanted. Then hence or otherwise determine the general solution of this whole thing is equal to this. So from our single trig ratio, which was a quarter, cos 2x is equal to 1 over 25. So multiply both sides by 4, so that the cos 2x is the same as 4 over 25. We need to find our reference angle, which means that 2x should be the fifth cos of 4 over 25. And this angle becomes what we have. So I have 80.79 from my calculator. This is going to be in quadrant number 1, because this cos is positive in quadrant 1, but it's also positive in quadrant number 4. So quadrant number 4, it will be 360 minus the 80.79, which gives me 279.21. So let me write my solutions. So I'm going to have x is equal to 80.79 plus k times 360, because that's the period of the first graph, divide by 2. This is going to be 40.39 plus 180 times k. K is an element in meters. That's the first quadrant. And then in the fourth quadrant, I'll have 2x is equal to 279.21 plus k times 360. Divide by 2. That's going to give me 139 plus 61 plus 180 times k is 111. So that's how we would get those general solutions. Okay. Question number 6. The trig graphs. They are telling us that in the diagram, the graphs f of x is this, and then the g of x is that. They are drawn within that interval, this and that and that. We have the turning points. Okay. Write down the period of f. So period of f for a sine and a cos, the period is always 360. So in that case, my answer is just going to be 360 degrees. Okay. And then for the amplitude of g, the maximum displacement, that's a negative one, that's a positive one. So the g the amplitude is the 1. Okay, and then the value of A, what does A represent here? So this A represents a shift. Okay, the graph was moved some units. So from the original cosine graph, we expect the turning point to be at 1. But now it's not at 1, it is around 45. So since the graph has shifted 45 units to the right, then this is going to be negative 45. Perfect. Then calculate the value of K, which is the Y coordinate of N and Q without the use of a calculator. So we know that 65, okay, let's take 165, is in quadrant number 2. Okay, when I look at quadrant number 2, that's gonna be like 180 minus 15 to give me 165. But we know that 15 is a half of 30. So there has to be a link. There has to be a link. So since it's just a 2-mark question, calculate the value of K without the use of a calculator. So what I can do, I can just substitute this in and say that the sine of 2 into negative 75 should give me a K. So this becomes negative 150. Negative 150 is found in the third quadrant. So if that is 90, that's going to be 60, this is going to be a 30. So which is the same as the sine of 180 plus 30, which becomes a negative sine 30. We know that the sine of 30 is a half, so which means K is negative a half. That is without using the calculator. Okay, then calculate the value of X if the G of X plus 60, which means the graph is being moved 60 units to the left. Okay, and then F. So where do we find the two graphs to be equal? So the two graphs are equal at this point, at that point, and then at that point. But now if the graphs are moved 60 units to the left, the question wants the values of X between negative 45 and 0. So if we subtract 60 here, it's going to give us a negative 15. If you subtract 60, it's going to be farther away. Subtract 60, it's going to be at 100, 105, somewhere there. But since they want the answer between negative 45 and that, which means our answer is just going to be negative 15. X is negative 15. All right, then 6.6 without a calculator, determine the number of solutions this equation has within the interval of negative 90 and a positive 90. So the negative 90 is at this point, the positive 90 is at this point. So when we look at solutions, it's like we are solving the two equations and getting answers. How many points do the two graphs meet? It's at this point and then at that point. So we know that it has two solutions, but how do we get the two solutions? Okay, so we can start by squaring both sides. Is it gonna help us? We can do that. You can square this side and then we square that side also. Because so when I square the left hand side, that's gonna be 2 sine squared 2x is equal to sine squared x plus 2 sine x cos x And then that is plus cos squared x. Is it going to make sense for me? Okay, so when I move this that side, I'm going to have sine 2x, and that's going to be negative sine 2x. This and this gives me 1 minus 1 is equal to 0. Okay, so I'm just working out everything in terms of sine 2x. So with this, if I open my two brackets, this is 2 sine 2x. This is a sine 2x. If I put a 1 and a 1 here, this has to be negative, this has to be positive. Then this is going to be sine 2x is a half, or sine 2x is 1. When I try to find my angles, the arc sine of a half is equal to x. We know that this is a 30. 30 divided by 2, that must give us a 15. Okay, so x becomes a 15. And then the arc sine of this is going to be 90. 90 divided by 2, we have a 45. Okay. But, whoa, this is a negative, not a positive. What's the arc sine of negative? Remember, we're not using 5 letter. Okay. Where do we find sine to be negative? It's in the 4th quadrant and the 3rd quadrant. So that's going to be 360 minus 30, which is love 30. Here it's going to be 2 pounds. Okay, so this isn't correct. 15 is not correct. So it's going to be 330 divided by 2, which gives me 165. Okay. And then if I look at the 210 divided by 2, I'm getting 105. Okay, but with the interval that we're given, we have this 45, then we got the negative 75. How are we getting the negative 75 from? Something's off here. What is 180 plus 60? It has to be 150 so that we get a 75. Because if let me take this out. Because if this is a 30, we expect the next one to be 150 down negative. I don't know how I'm ending up with Jakaraka. Okay, so negative 150 divided by 2, that's how we get the 75. So we have just 2 answers, but 2 solutions. Question number 7, the diagram ABC drawn. AD is drawn such that those 2 lines are perpendicular. Determine AD in terms of that. So we can say that the sine of B is equal to the opposite, which is AD, over the hypotenuse, which is AB. The question wants AD. So which means AD is going to be the same as AB sine of B. Okay. Then they're telling us hence prove that. So we know that the area of the triangles are half times the base times the height. Our base is a BC. So that's a half times BC times our height, which is AB sine of B. So that is how we prove that. Then 7.2, we're given the points B, C, and D that are lying the same horizontal plane. These angles are alpha, that is a theta, that's K, and then those 2 sides are equal. Can we prove that AD is the same as BC? So we can use the cosine regression, and we say that the cos of alpha is equal to the adjacent, which is the BD, over the hypotenuse, which is AD. Then AD is going to be BD over cos alpha. I'll do the same thing using this other triangle. Okay, I'll say cos alpha is equal to BC over AC. Then AC is also going to be BC over cos alpha. But we know that BC is the same as BD, which means these two are going to be the same. Therefore, AD must be the same as AC. Okay. And then can we prove this? So for me to prove this, I can use the cosine rule. I can use the cosine rule and say that DC squared is equal to DB squared plus BC squared minus 2 dB BC times the cos of which angle? I'm saying DC squared. Why am I going that through? That's going to give me issues because there is a cos theta. So that I don't want. Going to make my life hard. Let me start with the BC squared. Is equal to DB squared. Let's say BC squared minus 2 dB times DC, and then the cos of that angle, which is the theta. Okay, but we know that BC is the same as the BD. These two are the same, so I can just cross that out straight out. What do I want? I want a BD. I want a BD. I will have to BD. Okay, so DC is K. I can make this the side. So I'll have 2. What is dB? dB is the same as this. It's 2 dB multiplied by the DC, which is K. Cos of theta is equal to K squared. We want the dB, so divide both sides by 2K plus theta. So this divide by 2K cos theta divided by 2K cos theta. So this 2 cancels that, this cancels that, this cancels that. So left with the dB or VD. Cancel this K with one of the K. So K for 2 cos theta, just the way they want it. So we're going to use just the cosine rule and prove that. Then determine the area of BCD in terms of K with just a single cube ratio. Area of BCD. This. Now, remember, if you were to use the area rule, 2 sides are known. So this is known, this is known. We have the angle. We want just a single cube ratio. So what I'm going to do with that question is I can say that my area is a half multiplied by BD multiplied by BC or CD, and then the sine of theta. But we just say that our BD or DB is given as this, so I'll replace that. So this is going to be a half multiplied by the BD, which is K over 2 cos theta, multiplied by the DC, which is a K, and then the sine of theta. So this K and that K will give me K squared. Sine over cos gives me a tan. So K squared tan theta over 4. Okay, so that is our area. Question number 8. In the diagram, chords AB, BC, and AC are drawn to the circle. This is a tangent, BC is a tangent. Can we prove the tan chord theorem? So I'll use this side. That is question number 8. Okay. So what we normally do is that we have to start by the construction. Okay. So draw a line passing through the center, touching point C, or draw a line from C passing through the center to the circumference, and then connect this other part. Okay, so for having life easy on my side, I'll just let this be maybe X. Okay, you now call that X. Then we know that OCE is a 90. Reason, tan perpendicular to radius. Okay, so the whole of this is 90. So what is the size of OCB? That's going to be 90 minus X, because these two are complementary. Okay, then if that is true, let me call this A. It's fine. We can say that MBC, okay, is going to be a 90. Angle is semicircle. Okay, if that is a 90, then I can use my angles in a triangle. We say this is 90 minus X to find what M is. So I know that M plus a 90 minus X plus a 90 must give me 180. Angles in triangle. You don't need to show this step, but it's relevant. So M is X. Okay, so this is X. Then we can say that N is the same as A, because these are angles that are subtended by the same angle, angles the same segment, because we can see the bow tie. So you're going to say A is also A, angles in the same segment. Angle in the same segment. And then you just draw the conclusion, because we say this was X, and now this one is also X. Therefore, BCE therefore BCE is equal to A. Okay, so that is how you prove that. Should be 5 marks. Okay. Then 8.2, in the diagram, we have a cyclic chord. Let me just highlight the cyclic chord that we're talking about. Okay. R, that is that. S is a tangent, okay, to the circle is R produced, R2 is 68. Then they want us to get the size of P. So this P is an interior angle of the cyclic chord, so it should be equal to 68. The reason, tell us it's exterior angle of the cyclic chord. Exterior angle of the cyclic chord. Then Q1, we want us to get Q1. So if this is a 68, where is Q1? Q1 is in. So what I can notice is this S1, no, S2 is the same as Q1, because those are going to be angles opposite equal sides. Okay. And then we can see that these two are interior and 68 will be exterior. So which means it's going to be 68 divided by 2, which is a 34. So we can give these ones as exterior angle of a triangle, but start by telling us that the two angles are the same because of angles equal opposite sides. Then what will our S1 be? So we're calling this a 34. This is also 34. Then they want us to get S1, so we can use a tan chord. So this is a tangent, and it's going to also be 34. This is 34 degrees. Tan chord theorem. Okay, then question 9. Question 9, the diagram AB is a diameter, okay, with center AF, AB, and CD intersect at G, okay. FC are drawn, BA bisects, okay. So that word is crucial. And then they want us to determine, given reasons, any three angles that are the same as D. Okay. So with this, I can say that my A2 is a 37. The reason is going to be angles in the same segment, because we can see the bow tie in this format. So this is a 37. Then I can say that C2 is also 37, because it's going to be angles opposite equal sides. Because you know that this is a radius, this is also radius. But they told us that this line bisects, so which means A1 is also 37 degrees. The reason VA is a bisector. Those are three. But for as long as we identify this as a 37, we can also get D3 as a 37 because angles opposite equal sides. And then if that is true, I can also have another angle also. I think that's enough. That's enough. We don't need to populate this whole thing with 37s. Okay, so that is that. And then they want us to show that DG is the same as GC. In other words, they are asking you to directly prove that theorem of a line from the center. Okay, so for us to do that, we just need to make sure that either G1 or G2 is a 90. That is just the only thing. So what I'm going to do, I'll start by saying that BDA is a 90. And then that's going to be angle in semicircle. Okay, we can see that this line is a diameter. So that has to be a 90 to all of this. If that's a 90, we've identified this as a 37. So you're going to say 90 minus 37 minus 37, which gives us a 16. So D2 becomes a 16. If B2 is a 16, I can find my F1. Because this is a 37, this is also 37, so this is going to be an exterior angle. So I can say that F1 is going to be 37 times 2. That's exterior angle. So 37 times 2, that's 74. So which means G1 is going to be 90. So we have proved that this line is perpendicular. So if that is done, then it's a conclusion that therefore DG is the same as CG. The reason, the converse of line from the center perpendicular to the chord. We know that it must bisect the chord. Then if it's further given that the radius is 20, okay, so the distance, let me see, from here up to here is a 20, or from there up to there is a 20, or this is a 20, whichever format you want to tell. They want us to get the length of BG, this distance. So since we have our D2 as a 16, this as a 74, we can use, I'll prefer to use the trig ratios. Okay, this is 74, that's a 16. Then we have this as a 20. D is by 16. And then F is by the 74. And then G is by the 90. You want us to get B, G, B. This distance. Okay, so I'm going to start by finding my FG. Okay, let's get the FG. Then after getting the FG, then I shall be able to subtract it from the 20. So remember, we can use the Pythagoras theorem. That is going to be an issue. because some sites are not known. So just to save time, I'm going to use my sign. Instead, the sine of 16 is equal to ft over 20. So which means ft is 20 the sine of 16. That's what we want. Yes. Okay. So use your calculator. 20 sine of 16 is giving me 5.51 units. But we know that if the center is F, then the radius FB. So FB is a 20. For me to get my BG, I'll get 20 minus, I don't know, where is BG? Okay. 20 minus the FG. 20 minus FG, which is 20 minus 5.5. Okay, 5.51, which gives me 14.49 units. So that's how I also would have gone about that. Okay, that is BG, not DG, BG. Okay, then question number 10. We're being told that in the diagram, COD is a diameter to the circle with center O. EA is a tangent, and then AO is perpendicular. AO is perpendicular to that. This produced blah 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 is a tangent. And then we have OB in T, then these points are all true. Okay. Now they want us to prove with reasons why TO DF is a cyclic chord. DO TF is a cyclic chord. So what we can see is when we look at this, the question is, do we see any bow ties that can be created in here? Someone will say yes, someone will say no. So there are no bow ties. But one thing I know for sure, I can say that F2 plus F3 must give us 90 degrees. Reason, angle, you must say circle. Remember, they told us that this is a diameter, so this angle has to be 90. And then O2 plus O3 must also be 90 degrees. These are angles on a straight line. Okay, that's a minute. Now I can see that the opposite angles are going to be 180. So I'm going to say O2 plus O3 plus F2 plus F3 gives us 180. Or someone can say that DOB, rate of birth, plus DFT gives us 180. As long as that is true, therefore TODF is a cyclic chord. And then the reason is going to be the converse of opposite angles, the cyclic chord. Okay, so that is that. Then now we've proved that it's a cyclic chord, so I can try to draw some sort of circle there. If that is true, can we prove that D3 is the same as T1? So that since a cyclic chord, this angle here, T3, must be the same as T3. D3 must be the same as T3. So we're going to say that D3, we are now writing this, D3 is the same as T3. Reason is exterior angle, that's a cyclic chord. But we know that 3 is the same as T1. They are vertically opposite. Vertically opposite means therefore D3 is the same as B1. Okay, so that is for triangles. And then they want us to prove that these triangles are similar. Let me try to use different colors. So we have TFO. This triangle. Why can't I just take this out? Just once. Okay. So we say this is the same as that. Okay. Alright, so prove that TFO is similar to which one? To DFE. Okay. So we can start by saying that T3 is the same as D3. Return with proof that from up there. Okay. Then we can also see that F4, because this is a tangent, so F4 is going to be the same as C2. Or we can start by saying that C2 is the same as F2. C2 is the same as F2. Angles opposite, equal sides. Okay. But F4 is the same as C2, which is going to be the same as F2. So saying this angle here is the same as this angle, which means that output must be the same as E. The reason would be the remains of cheddar. So that was a term short for F4 to be the same as 2. That's a term short. Okay, so having obtained the three facts, we can say that therefore TFO is similar to DFE. Similar to DFE, reason, angle, then angle. And then 10.4, they want us to prove that BB is prior to EA if B2 is the same as E. B2 is the same as E. So what we can say is that D1 is also the same as B2. D1 is the same as B list. Because this is a radius. OB is a radius, even OD is a radius. So it's going to be angles opposite the sides. Okay, so if this is also the same, now we can say that E is the same as D1. So E is the same as D1. Therefore, DB is parallel with the reason it's going to be the converse of corresponding angles. Those angles are corresponding. And then 10.5. 10.5. They're asking us to prove that DO is the same as this entire thing. So where can I do that? Let me just erase this platinum. Let's erase that and then finish the paper. Okay, so what we're going to do? I'll start by comparing the sides of the similar triangles. Does that make any change, any impact? So I'm going to say that from my similarity of proving that the triangles are the same, I can come up with something to say that ED over TO, ED divided by the TO should give me the same as EF over OF or FO. The reason is going to be similar triangles. Similar triangles, or you can tell us that this is partly similar to that. Then if that is true, then I can say that TO multiplied by EF, or they are using FE. This must be the same as ED multiplied by 4F. Okay. Then we just need to get another aspect that will just give us the whole thing. Then what we're going to do? From the proportionality theorem, because remember we just proved that some lines are parallel. These lines here, they are parallel. So if I have this and that, so I can say that my DO over DE is the same as OB over AD. The question wants us to make DO the subject. Okay, so if I make DO the subject, I'll be left with DE multiplied by the OB over our AB. So the reason for this, we're going to say proportionality theorem, because DE is prior to EM. It's DB prior to EM. Okay. Then let's see how do we break this down. We know for sure that our ED, where is ED, is in proportion with the AB. That's okay. And then we also know that, why am I using this? I don't need this. Let me use this OB. We know that OB is a radius. Okay. OB is a radius. And then we also know that OD is also a radius. Where is that taking me? Because I know I have my DP here, or ED. So okay, let me do the subject. Because I'm going to have TO times FE divided by 4F. OF. Okay, that's fine. It makes sense. Okay, so I'm going to replace this. So that's going to be TO multiplied by FE. Okay, then I'm multiplying by 4B. Then I'm dividing it by the AB. Then I'm multiplying it by the FO. So what we're saying is that FO is the radius. Okay, but then our OB is also a radius. So this is going to cancel that out. And then what I'll be left with is what the question wants me to prove. So guys, that is that. On the overall, I can say the paper was fair. Okay, so thank you very much, and then all the best the remaining exams till we meet again.